The James Webb Space Telescope has captured something totally amazing. Lights that seem to be emanating from a city shining from a distance of 4 light-years. This finding has rekindled interest in the possibility of extraterrestrial life. The telescope focused its argument on Proxima Centauri b, the closest exoplanet to our solar system, and detected unusual bright flashes. Is this proof of an alien civilization? Keep watching. Scientists and ordinary citizens alike have been eager for long to imagine what existence beyond our world would be like. Any science that attempts to suggest anything exists beyond has always been eagerly received. Then came a game-changer with the James Webb Space Telescope with conclusive proof of life somewhere within the universe. Scanning the expanse of space, this powerful telescope detected something unusual on Proxima Centauri b, a distant exoplanet. It detected lights similar to those from extraterrestrial cities, leaving it open to the possibility that there is an extraterrestrial city on the distant planet. This possibility has generated huge excitement and interest among scientists, who are intrigued because this could be one that they have been waiting for. It suggests that there can be intelligent life elsewhere in the universe, organizing their societies in ways we are only just beginning to discover. Staring out at these distant city-like stars some incredible 4 light-years away, NASA engineers are amazed and ask how long they have been shining in space, waiting for our technology to advance enough to detect them. David Kipping, an astronomer at Columbia University, said the planet where the lights were found was quite complex. This is because, unlike most rocky planets that absorb sunlight and emit energy in the forms of infrared, this exoplanet operates differently due to its unique connection with its parent star, Proxima Centauri. The fact that this was made by the James Webb Space Telescope makes it even more important. The infrared wavelength capturing ability of the telescope turned out to be instrumental in detecting Proxima b's unusual activity, which is the solution to knowing the atmospheric state of this planet. Scientists plan to continue utilizing this telescope to observe the atmosphere of this planet in depth and even whether it can support life. The James Webb Space Telescope is also especially sensitive to infrared light, meaning it will be able to view what is happening on Proxima Centauri b in the dark. Most telescopes struggle to detect weak light amidst the vastness of space. The James Webb Space Telescope can detect even faint glows of light. This makes it an ideal tool to check if the suspected city lights on the dark side of Proxima b actually exist. The telescope can detect any artificial light in space if it falls within a very thin frequency band, much thinner than regular starlight. Proxima Centauri b has a dynamic relationship with the star. One half of the planet confines the star's intense energy, and its spectrum also scatters light. When a planet orbits Proxima Centauri, it experiences a day and night cycle similar to that of Earth, with blistering heat during the day and colder temperatures at night. The planet experiences more temperature fluctuations, which are based mainly on its nature. For example, because Proxima b lacks an atmosphere, diurnal temperature fluctuations would be extreme. Without the moderating influence of atmospheric gases or the oceans, the day side would get incredibly hot and the night side would get as cold as close to 0 degrees. This extreme thermal fluctuation is of great interest to astronomers, as it is a clue to the atmospheric composition of Proxima b. The James Webb Space Telescope's infrared imaging expertise enables it to efficiently study the thermal radiation of the planet and derive valuable information about the character of its atmosphere. Surprisingly, the orbit of the James Webb Telescope around the Earth coincides with Proxima b's orbital period, enabling accurate monitoring of its day-night cycles every 11.2 days on Earth. If the planet is atmospheric, the next step will be to analyze its chemical composition to determine its ability to support life. Signs such as the presence of oxygen, water vapor, and methane would be an indication of habitable conditions. If these elements are present on a planet, it would be an indication of its ability to support life. This would involve analyzing the light that passes through the planet's atmosphere, a complex process. Though the James Webb Telescope is excellent for the characterization of planetary atmospheres, it is not particularly designed to do so. It is designed for learning about changes in water vapor, carbon dioxide, and methane concentration levels. Although it cannot find free oxygen, the most critical sign of life, the telescope can also seek out other important constituents such as ozone, which indicates a healthy environment. As researchers analyze the data collected by the James Webb Telescope, the search for distant worlds leads us closer and closer to discovering whether we are alone in the universe or not. It should be noted that the James Webb Telescope can only see a few exoplanets close to Earth. For more accurate investigations of the atmosphere, astronomers will employ ground-based observatories such as the Extremely Large Telescope, ELT, which will begin operating in 2028. The ELT will be employed to get a closer look at the atmospheric contents of distant exoplanets, providing unobscured and detailed information about whether they can support life. Scientists are looking forward to the operation of next-generation space telescopes such as the ELT. At the same time, however, the James Webb Telescope is still an indispensable tool for examining distant exoplanets. With all its drawbacks, the Webb Telescope continues to provide valuable information that can help transform our vision of what lies beyond our galaxy, not only today but even in the coming years. Astronomers have big plans for future space telescopes. They hope to create technologies that dim starlight in order to view the planets closer to them. It is like shielding your eye from the sun with your hand to see more clearly. Dimming starlight, these next-generation telescopes will be able to view the dim light that is reflected off exoplanets more precisely and evaluate their atmospheres and see if they could contain life. This is still a significant challenge to accomplish. It is said rather than done to shield starlight to observe exoplanets. Stars are highly luminous, typically dominating the planets nearby by a number of orders of magnitude. That renders it difficult to discover the feeble light scattered by planets, which is imperative to examine their properties. In an attempt to get past this issue, researchers are devising numerous new ways. One such technique is the use of coronagraphs. These devices are placed inside the telescope and are designed to block the starlight but allow the light from the planets to pass. By bending the light waves with high accuracy, coronagraphs can reduce the glare of the star to a large degree, and the weak light from the exoplanets is easier to spot. Another device that is being developed is the Starshade, a gigantic flower-shaped space vehicle that travels alongside the telescope. Placed tens of thousands of kilometers away from the telescope, the Starshade is in front of the starlight before it even reaches the telescope, with only the light of the exoplanets passing through to the instruments. This method would be extremely effective for surveying planets in the habitable zone of their stars, where liquid water and perhaps life would exist. Both of these technologies, however, would require an otherworldly level of precision. The positioning of a starshade, for instance, must be impeccable to fractions of a millimeter across enormous distances. Furthermore, these technologies need to transcend the constraints of space missions, i.e. miniaturization, energy efficiency, and the tolerance of space environments. In spite of all this, the possible gains are gargantuan. Making it successful to observe and study the atmospheres of exoplanets would unlock the doors to the possibility of finding biosignatures, chemical signs of life. Substances such as oxygen, methane, or water vapor in exact quantities could be indicative of biological processes and suggest that there exists life somewhere other than our own world. Scientists are also looking to directly image such faraway worlds more accurately. Future telescopes can be equipped with advanced adaptive optics, correcting for the distorting effect caused by the atmosphere of the Earth or the wobble of the telescope, rendering sharper images. With the blockage technologies by starlight, these developments would not only permit scientists to be able to identify exoplanets but also surface map them and study their climate. The development of these next-generation space telescopes is a giant leap towards finding one of the most basic questions of mankind. Are we alone in the universe? By revolutionizing our ability to gaze at distant planets, we bring ourselves nearer to finding out if life does exist anywhere in the universe,